Yo, boys, we are live. 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 Yo, boys, we are live. 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 Okay, guys, it's time to start the stream. Let's go.
I can feel you everywhere, like a shadow, like a fever. Looking for a getaway, no escape, I'm going deeper. I can't fight my way out, I can't fix my broken heart. If you could only let me go, our love turned into a war. It's hard, I ain't coming back. If I win or lose, I don't even know. I don't mind. Set me free. Let me follow. Trapped inside, I can't fight anymore. Let me breathe. Who was before? I'll be better alone. Set me free. Let me follow. Trapped inside, I can't fight anymore. Let me breathe. Who was before? I'll be better. Let me breathe.
Welcome to the stream, y'all. Welcome to the stream, y'all. Welcome to the stream, guys. Welcome to the stream, guys. Welcome to the stream, y'all. Welcome to the stream, y'all. Welcome to the stream, guys. Welcome to today's stream. So, today I'm trying to bring you guys even more value than usual. So, what is today's game plan? What is today's game plan? So, today's game plan, man, is the following. So, first off, I have prepared some useful questions which I'm gonna teach you guys how to do. So we're gonna learn how to convert from decimal to a base. So we're gonna convert from number from decimal to base. Then we're gonna learn. Then I'm gonna teach you guys how to convert number from some base to decimal, and then I'm gonna teach you how to convert from number from one base to another. Okay. After that, we're gonna look at this question: find nth magic number, which is a bit manipulation and bit math question. All right, then we're gonna do that. After that, we got some code forces problems prepared here to solve. Okay. We have some code forces problems prepared here to solve. All right, and in case we run out of stuff, we're gonna do some of these ones, but I think we are not gonna run out of stuff, so that should be fine. That should be fine. Okay, that should be fine. So without further ado, first we're gonna start with converting one base to the other. So we have the following question: convert number from one bit from decimal to some base. So how do we do this? How do we do this? We do the following. We get the remainder from dividing the number into the base. Then we add that remainder. We're going to store that remainder in our answer. Then we're going to divide by that base until n reaches 0. And then we're going to reverse the answer since the digits of that base are going to appear in reverse order. So for example, let's say we want to convert let's say we want to convert let's say we want to convert to base. So let's say we want to convert from let's say we want to convert 10 from base decimal to base 2. So from base 10 to base 2. So what are we gonna do? So first we are going to we're gonna start dividing 10. We're gonna start dividing 10. So we're gonna divide 10. We're gonna divide 10 by 2. Okay, this is not okay, let's move this, and then we're gonna divide 10 by base 2. This is by the base, and we're gonna keep track of the remainder. So remainder is 0. When we divide 10 by 2, the remainder is 0. So then 10 becomes 5. Then we're gonna divide by base 2 again. Now the remainder is 1. Okay, now the remainder is 1. Then we get 2. Okay, so we're gonna divide by 2, which the remainder is going to be 0. Okay, the remainder is going to be 0 right here. And finally, when it becomes what the heck? Why is it shining like that? What happened? Okay, what the? Okay, it glitched. Okay. So, okay, let's delete this, and I don't know what happened. So the remainder is equal to 0. Like this. When we divide 2 by 2, the remainder is 0. Finally, we have 1 divided by 2. And now the remainder is 1. Okay? And basically, so we have 0, 1, 0, and 1. We write it in the reverse, and that is 1, 0, 1, 0. Okay, and we can even check this. 2 to the 0th is 1. So 1 times 0 is 0. 2 to the first is 2. 2 times 2, no, 2 to the 0th, 2 to the first. So this is 2. Then this is 6. No, this is 4. Yeah, this is 4. Then this is 8 to the. This is 2 to the third, which is 8, and we have 8 plus 2, which equals to 10. So this is basically how we convert from one base to the from base 10 to some base. So let's try this example in the code. So we're gonna say cout convert to base, and we're gonna do exactly what we did just now. We're gonna convert from base 10 to 10 from base 10 to base 2, or to binary. So right now we're just gonna compile this, And we're just gonna run it, and we should get 1010, which is that. Okay, that is what we should get. What happened? Okay, what happened? CC out hello, hello, or something like G++ base convert CPP dash O. Okay, the solution is right. So convert to base. Okay, yeah, this is correct. Okay, let's try it again. Base convert CPP. Base convert EXE. Taking a while, guys. Okay, there we go. We get it. We finally got it. 1010. That is our answer. That is our answer. I think I didn't save the file, and that's why that happened. I did not save the file. Now let's try something else. I'm gonna convert to base. Let's say I want to convert 10 to base 8. So I want to convert 10 to base 8, and that should give me 12. Okay, convert. Okay, so now we should see 1010 and 12 and 12. 10, 11, yes. Let's see. Okay, there we go. 12. So that's it, guys. That's how we convert from base decimal to a base. We divide the number by that base until it becomes 0, and at every division we keep track of the remainder. And after we have all the remainders, we write them in reverse. Okay, so now actually let's look at the actual function. Let's look at the actual function, which is okay. Turn this off. Which is right here. So this is the function. Let me close this. So first digits. This is where we're gonna keep track. In this array, we're going to keep track of our remainders. So the remainders we are getting from the division, we are going to put them in this array. And as we can see, while n, so this loop is gonna run until if n is a true value. So a true value is basically anything that is not 0. It can be 1, it can be 2, or whatever. But when n becomes 0, it will become, this loop will terminate. So we use this to get the remainder. So we're going to append the remainder of the current number divided by base. And as we can see in the case with our example, the first remainder when we divide 10 by 2 is 0. So in this case, let's imagine that 10 is hey, yo, welcome back. Glad to see you, man. Glad to see you. Thank you. Welcome to the stream. I'm glad to see you. How are you doing? Okay, so where was I? Alright, so in our example, when we use 10, first 10 divided by 2 gives a remainder of 0. So this is what we're going to put in the array initially. We're going to put 0, then we're going to divide n by the base. So we're going to divide, so let's say that n is equal to 10. We divide 10 by 2, and then n is going to become 5. So on the next iteration, n is 5. Now we divide n by 2, and this is equal to a remainder of 1. This is equal to a remainder of 1. So we're going to, right here, we're going to put that remainder inside the digits array, and then we're going to divide n by 2 again. And now n is going to become 2. Now we divide n by the base, which is 2, and we put the remainder inside digits. So the remainder now is 0. So what we have right now in digits, right now we have 0, 1, and 0. Okay, this is what we have in digits right now. 0, 1, and 0. And on the last iteration, when n is equal to 1, the remainder when dividing 1 by 2 is gonna be 1. Okay, so now digits is going to be equal to 0, 1, 0, and 1. And then this becomes, right now, this becomes, and when we divide n by 1 by 2, it's gonna become 0. So now we have all of our digits here. Okay, and then we just reverse the array. So when we reverse this array, it will become 1, 0, 1, 0, which is 10 in binary. Then we have our answer variable where we're gonna put the answer, and on each iteration we are going to add a digit from this to our answer, and if it is not the last index in the array, we're gonna append that by 10, and finally we're gonna return the answer. That is basically how we get 1010 right there. That is how that works. That is how that works. Okay, that's the first one. The next one is convert number from, okay, no, not this one. Where is it? Okay, so the next one is convert number from some base to decimal. And let's get rid of this. Let's get rid of that. Okay, so the next question is convert a number from some base to decimal. So the approach we do, we multiply the digits in n with base to the power of I. So if we are at the 0th, so let's say we're trying to convert from binary base to decimal. So we're going to multiply, and this is going from right to left. So that this is going from right to left. So first it's 1, this is 1, this is 1 right here, this is 0, this is 0 right here, 0 right here, 0 right here, and then 1 right here, and this is this one right here. Okay, so what we do, we multiply the digits in the number with whatever the base is. In this case, the base is base 2 to the power of I. So this is the ith bit, the ith digit. We start with 0 indexing. So this is 0, this is 1, 2, 3. So first, okay, what did I do? So first we have 1. So we're going to multiply 1 by 2 raised to the power 0. Then we have 0. We're going to multiply 0 by 2 raised to the power 1. Then we have 0 again. We're going to multiply, so this right now, this is 1. So then we have 0 times 2 to the power of 2, which is 4. It's going to give us 0 as well. And then we have 1 times 2 to the power of 3, or this is going to give us 9. 9 in decimal, okay? Because this is 1 and this is 8. 1 plus 8 is 9, and all of these right here are multiplied by 0, so this is plus 0 plus 0. Alright, and we're going to use that exact GG, continue your journey, bud. Thank you so much, bro. Thank you so much. I will. Have a great one, man. Have a nice day. Thanks for stopping by. So, we're going to say base to decimal. This is one. Okay, so yeah, we have the number, we have the base, so we have 1001, and then we have the base, which is 2. And right now, this is going to give us 9 as output. This is going to give us 9 as output. Okay. This is going to give us 9 as output. There we go. So let's say we want to convert 15 from base 8 to decimal. So just a sec. So we have 10 is 8, 11 is 9, 12 is 10, 13 is 11, 14 is 12, 15 is 13, so we should get 13 right now. We should get 13. Let's see, because it's base 8. Let's see, yeah, 13. And then we should get, now we should get 14. We should get 14 right now. We should get it any second now. There we go, 14. Okay, that's how that one works. That's how that one works. We multiply the digits of the number times base to the power of I. So right here we have 1 and 6. So we multiply 6 by 8 raised to the power of 0, and we multiply 1 by 8 where's 8 to the power of 1. So we're going to get 8 plus 6, which is equal to 14 in decimal. Okay, that's it for how to convert from any base to decimal. That is that one. Let's look at the code. So let's look at the code. So we have, so answer is initially 0. This is what's going to keep track of the power in each. So while n, we're going to keep dividing, because so we can get the next digit. We're going to keep dividing by 10. So on each iteration, the digit, so n modulo 10 is going to give us the last digit of the number, and we're going to multiply that digit by the base to the power of power, which is 0 right now. So if this was the 16 example, first we're going to have 6 times 1, because 8 to the power 0 is 1. Then we're going to have 1 times 8 to the power 1, which is 8, and that is 8 plus 6, which is 14. We increment the power on every iteration, and we remove 1 digit from the end of the number. And once all of the digits are removed, we break out of the loop, and that's how we get our answer. Okay, that's it for that one, done and dusted. That one is done and dusted. Okay, the next one and the final one, which I'm gonna teach you guys from this batch, is how to convert a number from one base to another. And this is very simple. Since you already know how to convert from decimal to base and from base to decimal and from base to decimal, now you just have to convert the number from the base to decimal. Okay, from the base you are given to decimal, and then you gotta convert the number from decimal to the other base which you want to convert to. So let's say we have a number from base 2, we want to convert it from to base 8. So first we're gonna convert the number from base 2 to decimal, and then from decimal we're going to convert it to base 8. And basically this right here is the code. We already have the functions, so basically just we are going to just we use base to decimal. So we're going to convert first the number from base 2 into base 10, which is this n is this from is 2, the base 2, and this 2 is the base 8. And after we have the number in decimal, we are going to convert from decimal to the other base, which is 8. So 8 and base 10 is 8, and 8 and base 8 is 10. And that's what we get in our answer, and then we're gonna return the answer. So let us try this out. So we're gonna see out from base to base, it's gonna be 1 1 1, I think, from base 2 to base 8, and we're gonna see that we are going to get, so this is 1 2 4, yes, we're going to get 10. If I save the file, hopefully I saved it. Don't know if I saved it. I think I did. Okay, there we go. We get 10. Okay, guys. So that's how you convert from decimal to a base, from base to a decimal, and from one base to another base. And with this, there are so many questions and problems which you can solve when you know this. So that is why I wanted to show you guys this. Okay, so that's it for that. Now let us look at this question. It's called find the nth magic number. So this is the statement. We want to find the nth magic number. So a magic number is basically what a number which from the binary representation of n, when you multiply 5 by the ones in the binary representation and you add up all of the multiplications, you get that number. So the first magic number is 5 because n is equal to 1, and 5 to the power of, so this is the 1 2 3. Here it's not 0 index, it's 1 index. So 1 2 3, and right here this is going to be 5 because this is 1. So 5 to the first power, 5 to the power of 1 is going to be 5, and then we're gonna multiply 5 by 1, and this is gonna be 5. Then we have 5 to the first power times 0, so that's 0. Then we have 5 to the second power times 25 times 5 to the second power, which is 25. So 1 times 25, that's 25. And then we have 5 to the third power, which is 125. which is 125 times 0. So basically we get 0 plus 25 plus 0, and that's how we get 25. Now the third magic number, when n is equal to 3, we have 5 to the first power, which is 5. Then we have 5 to the power of 2, which is 25. So we have 5 plus 25. Then we have 5 to the power of 3, which is 125, but it's 0. This is 0. So 125 times 0 is 0. So we got 30 plus 0, and that's how we get 30. Okay? Yeah, and here's the approach. Check what is the last bit of the binary representation of n. If it is 1, add 5 to the power of number slash index of bit counted from right to left, starting at 1. If the bit is not set not 1, do not add power of 5. Do not add 5 to the power of index to the answer. Increment the power on each iteration. And this is the code right here. So at first, the index is 1. So, and the answer is 0. So this is how we get the last bit in the binary representation. N and 1. Okay, this is how we get the last bit in the binary representation. Like this. Alright, and if the current bit is 1, we're going to increment answer by 5 to the power of index, which in our case, when n is 1, n and 1 is going to give us 1, and we're going to add 5 to the power of 1 to the answer. Then we're going to increment the index, and then we're going to shift n to the right by 1. So basically, if we have 0, 0, so if n is initially equal to 1, and then binary n is equal to 0, 0, 1, and then when we right shift n by 1 is going to be equal to 0, 0, 0. And this is what keeps us from having an infinite loop. When you shift a number to the right by 1, you're going to divide it, and this is how we don't get an infinite loop. Okay, so, and yeah, we do this, and that's basically it. We return the answer. So let's now let us now see. These are some test calls right here. Was plus dash o find env.exe. We're gonna compile this. Okay, what just happened? Okay, I have no idea what I just did. Okay, I placed the O where it shouldn't be. Hold up. So let's clear this plus g++. Env find dash o, and hopefully it's not gonna completely break now. Okay, so now we're gonna do that. So then to env.exe, and then this should give us the answers in like 5 seconds. I don't know why, but it takes so long when I'm running a C++ solution. Okay, there we go. These are our answers. So our third magic number, as we have written here, is 30, because it's 5 plus 25, 30. Then our fourth magic number is 125. Our fourth magic number is 125 because 4 is equal to 110 in binary, and Wait, no, actually, no. It's equal to 1, 0, 0, and binary. And this is 5 times 1, 5 times 5, 5 to the first, 5 to the second, 5 to the third. 5 to the third is 125. Then we have magic number of 5 is going to be, because this is 1, 1, 0, 1 in binary. And this is 5, this is 125. 125 plus 5, that is 130. And then finally, and when n is equal to 6, this is equal to 110 in binary. So we have 25 plus 125, which is 150, and that's that one. That is that one. Hello, what you doing? Welcome MD Fahim to the stream. So right now I'm trying to teach you guys uh, some problem, some DSA concept. So I already went over how to convert a number from decimal to base. I went over how to convert number from base to decimal, and I went over how to convert number from one base to another. And now when you know this stuff, you're gonna be able to solve a lot of DSA questions, because of this stuff gets asked decently often in questions. And now I just explained a question right here, which is called convert, which, no, wait, no. I explained a question right now, which is find the nth magic number, and now we're gonna jump into some code forces. Gonna jump into some code forces problems. That's what's going on. Can you guide me? I am a fresher and I just passed 12. What do you need? Just passed 12. What do you need guidance with? What do you need guidance with? I'll see if I can give you advice. Okay, so that is what I wanted to show you guys in here. Now let's try some. Let's try to solve some of these. Let's try to solve some of these. So this is the first one I've prepared. So Cernal's perfect bitmask classroom. Cernal perfect bitmasks. She has just started. Cernal gave her students a positive integer x. As an assignment, her students need to find the minimum integer y which satisfies the two following conditions: x and y greater than 0, x XOR y greater than 0. Where and is bitwise and XOR is bitwise XOR. Among the students was someone who was truly baffled. Okay, we don't really care about this. So basically we just need to find the first number. So we are getting an integer x as input, and basically we want to find the first number, a minimum positive integer y which satisfies the two following conditions. Okay, so we need to find the smallest possible number, positive integer. So this is gonna start from 1, which when we AND it with that one with x is gonna be greater than 0, and which when we XOR it with y, it's gonna be greater than 0 as well. So that is basically what we need to do. So we need to get t, we need to get c, and this is our number of test cases. We need to get that, and then while t minus minus, actually I think I can say no. So while yes, okay, we have n, and we're gonna actually x, cn x. So while I'm gonna have while true, and here we're gonna have we're gonna have int I is initially equal to 1, and then we're gonna say if x and I, actually this should be y. Let's name the variables appropriately. So if x and y is greater than 0 and x XOR y is also greater than 0, we're going to see out, I think, y. We're gonna break, and we're gonna have I plus plus, y plus plus actually. And yeah, I think that's it. Let's try to run this. Okay, let's try to run this to see. I know basics. I mean, right now I'm also kind of on a basic level, so I can't really guide you that much. I mean, you should. What I can tell you is you should just solve problems by topics and try to solve problems which are a little bit challenging to you. So, for example, if your rating on code forces is if you have 1,000 rating on code forces, try to solve problems which are 1,000 and 100 rated. That's gonna I think that's gonna be useful in Python. I mean, you can solve them in Python as well. I just use C++. You can solve them in, I know basics. Oh, so wait, have you done any sort of data structures and algorithms, or do you just know the basics of how to use Python? Because I didn't quite get you. So you haven't done any. So you haven't done any DSA then? Is that what you're trying to say? Okay, let's so 7, 1. Okay, we get 3. Then we have 2. We should get 3 again. Okay. Then we have 5. Which is it 5? Yeah, 5. We should get 1. Then we have 9. 9. We should get 1 again. Should get 1 again. 9. And then I'm not gonna try to write this. We have this, and we should get 17. 7. What? Okay, something isn't right then. Oh wait, it's 16. It's 16. So that, yes, that one is 2. So I missed 16. That should give me 17. Yes. And then it's this one, and that should be 64. 64. Okay. Okay, let's submit this. Let's submit this. So this is 1688A. 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 Let's submit. Okay, let's see if we get some sort of wrong answer or something. This is not. Okay, I think it may be stuck. Sometimes the problems get stuck. Sometimes the problems get stuck. Okay, it seems it's stuck. Let me refresh again. Yeah, so it seems too many submissions are happening on the website. So let's move on to the next one. Let's move on to the next one, which is this one. Okay. We're gonna move on to this one. So this is called recurring a small string. So it's a brute force one. Okay. Nikita had a word consisting of exactly three lowercase Latin letters. The letters in the Latin alphabet are numbered from 1 to 26, where the letter A has index 1 and Z has index 26. He encoded this word as the sum of the positions of all the characters in the alphabet. For example, the word cat, he would encode as the integer 3 plus 1 plus 20 equals 24, because letter C has index 3, A has 1, and T has 20. However, this encoding turned out to be ambiguous. For example, when encoding Ava is 1 plus 22 plus 1 is also, and the integer is also obtained. Determine the lexicographically smallest word of 3 letters that could have been encoded. Smallest word of 3 letters that could have been encoded. Okay. A string A is lexicographically smaller than a string B if and only one of the following holds. A is a prefix of B, but A does not equal B. The first position where A and B differ, the string A has a letter that appears earlier in the alphabet than the corresponding letter B. Okay, so A is a prefix of B, so graphically smaller, if and only if one of the smallest word of 3 letters that could have been encoded of 3 letters. String A is lexicographically smaller than string B if and only if one of the following holds. A is a prefix of B, but A does not equal B. In the first position where A and B differ, the string A has a letter that appears one of the following. So this is or. In the first position where A and B differ, the string A has a letter that appears earlier in the alphabet than the corresponding letter. Differ. The string A has a letter that appears earlier in the alphabet, the corresponding letter B. These cases, so 1, 2, 3, 4, 5. The first one, only line contains, each test case contains an integer. The encoded word for each test case looks for the smallest 3-letter word that could have been encoded on a separate line. Okay, so descriptions of the test cases. The encoded word. So basically, so we have A, and V. So A is the first letter of the alphabet, and then I don't know which letter V is. A, and V. So this is 24. 24, so we print A. So graphically smaller than a string B. Then a string B is smaller than the string B if determine the smallest letter of smallest word of 3 letters that could have been encoded. Nikita has a word exactly 3 lowercase Latin letters. The letters the Latin alphabet are numbered from 1 to 26, where the letter A is index 1, letter Z is index 26. He encoded this word as the sum of the positions of all characters in the alphabet. Cat would be called 3 plus 1 plus 2, 20, 24, because the letter C has the index. In the alphabet, the letter A has the index 1 and the letter has index 20. Okay, yes, however, this is going to turn out according with Ava, the integer is also obtained. Determine the lexicographically smallest word of 3 letters that could have been encoded. very small, 3 letters. So basically, we want the minimum. That is 1 plus 1 plus 1. Okay. So I think maybe we're gonna have to run 3 for loops inside each other. I think A is a prefix of B, but A does not equal B. Smaller than a string B. In the first position where A and B differ, the string A has a letter that appears earlier in the alphabet that corresponds to the letter B. "24, 73, 55. Okay, I think this is a brute force, so I'm gonna try 3 for loops, 3 nested for loops, and we're gonna see what happens. So we're gonna have T, T, wow, T minus minus. We're gonna have N, N, Cn, N. Then we're gonna have 4, and I gets A. No, actually, gets A. I guess A. And I. So char I gets A. I isn't equal to Z. I plus plus. Okay, I think I'm gonna try to keep a map. A map of char and int called letters, and I'm gonna for char I gets A. I less than equal to Z. I plus plus. I'm gonna have int J or something equals to 1. Letters of I equal J, J plus plus. Okay. And then we're gonna run the 3 for loops. So for int I gets A, I less than equal to Z, I plus plus. For int J gets for int, let's say P or something, gets A, I less than equal to P less than equal to Z, P plus plus. For int K gets A, K, K less than equal to Z, K plus plus. If letters of I plus letters of P plus letters of J is equal to, what is it, to N, see out this with an N line, and then we're gonna say bool flag equal false, and then we're gonna say flag equal true, and then it's gonna be if flag break and here as well if flag break. Okay. Okay. Alright, so let's see. Okay, okay. Like I'm training gonna break. And yeah, I think that's it, but we shall see. Let's try it. Okay, so in here we need a semicolon, semicolon. Okay, so 524. Okay, no. Okay, so we need a string, so two, oops, just stop this. Okay, we need to see out. Actually, this is I plus P plus K. It's not letters. Okay, so let's try 24. Okay, what the heck? 313. Okay, so it should have been 113. Wait, no. So we're gonna say, okay, let's say two string I plus two string P plus two string K. So I is A, P is yeah, and K is this. Okay. 24. Okay, what the heck is going on, man? I plus letters of P plus letters of, oops, not of J, of K, of K. 524. Okay, still something is not right. So P plus letters of string K. Okay, okay, let's see out the map for auto P letters. Let's see out P dot first, P dot second. And actually, let's create this outside. Let's create this outside of the loop so we don't create it every time. Okay, let's see now. Okay, A, B, C, D, E, F, G, H, I, E. Okay, that seems to work. so that's not the issue. That is not the issue. Okay, so let's, instead of doing this, let's see out I, P, and K. Let's see. Okay, what in the heck? Oh, these are int. It should be char. 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 Then let's do plus this. Okay, I wonder if it's gonna break again though. Okay, so it does break. So okay, let's just try to see out them like this. Okay, let's try 4. Okay, very nice. Seems to be getting the answer. Let's try all test cases. Okay, so 5, 24, AAV 70 should be RZZ. Okay, then 3 should be AAA. Alright, then 55 is CZZ, and then 48 is AUZ. Okay, it seems to be working. Let's submit. I mean, this is rated brute force, so it should pass. So this is 1931A, 1931A, 31A. Okay. Okay, we got the time limit exceeded on the last one. What happened? Okay, I guess something is wrong here. Okay. Okay, still in queue. Okay, let's move on to. Okay, guys, it's already. Actually, guys, I was going to move on. I was going to. Okay, so be a. Hold up. Let me do this so I don't dox my email again. Submissions in queue still. Okay, this one has a lot of test cases. Okay, guys. Should I do this or should I end stream? Okay, let's see, depending on how fast I get it. If I get it like fast, I'm gonna do it. If I don't get it that fast, I'm gonna end the stream. So given a string x of length n and string s of length m consisting of lowercase Latin letters, you can apply a number of operations to string x. If in one operation you append the current value of x to the end of the string x, Note that the value of x will change after this. For x, if x equal ABA, after playing operations, x will change as follows: ABA, maybe ABA. Okay, after what minimum number of operations, S will appear in X as a substring. A substring of a string is defined as a contiguous segment of it. And a string S. So after what minimum number of operations, S will appear in X as a substring. Okay. Two numbers, the lengths of string S and X, repeat X and S respectively. The second line contains string S of length N. Output the single number, the minimum number of operations after which S or print in X as a substring is not possible. Print -1. Okay, so minimum, so this is X. So this should be 1, 2, 3, 4. Should be, oh, 3. In the first test case, after 2 operations, oh, so we append the whole string? What? A, B, A, A, B, A, B, A, 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 A, B, A. So basically we double it. So we double this. So this is gonna be times 2, and then this is gonna be times 2 again. A B A A B A A A B A B A A B A A B A A B A. Okay. So we double this. This becomes AA. Then we double it again. It becomes, wait, then what is, then it becomes, so we AA, then we double it again. 1, 2, 3, 4, 5. Oh wait, the output is right here. So we add, which is after S will appear in X as a substring. String X. So this is X and this is S, which S will appear in X as a substring. S will appear in X as a substring. So this is, yeah, we double it. So it becomes, first it's A, then it's AA. So one operation, A, AA. Second operation, A, 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 A. Third, A, 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 A. So 3 operations, yes. Okay. All right. Okay, did that. Okay, so I think I got it. I think I got the idea. Okay, so first we are gonna get we're gonna get T. First we're gonna get T. Let's comment this out. So we're gonna get int T, cnt T, while T minus minus. Then we're gonna get M and N, int M, N, M and N, no, N and M. CNN, M. Then we get S string XS, CN, XS. Okay. So we're gonna have int operations equal to 0. Okay. After which s will appear in x as a substring. So this second one should be 0. What? Where is it 1? Force. Oh, we add e force. So it's e fork, then it's e fork, e fork. So that's force. So that's one operation, yes. Okay. Okay. Okay, guys. I mean, uh, okay. So we just need to find out if how do we find out if the substring is contained in a string. That is what I'm trying to think about right now. Um, mm, 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 mm. After three operations, yeah, one, two, three, four, 1, 2, 3, 4, yeah. Okay, let's think about adding the. Let's think about adding the. So int length to add at first is gonna be 1. Okay. So 4. So we have x. So 4 int equals 0. I less than length to add I plus plus. I plus plus. Hmm. I plus plus. Hmm. Okay, guys, I'm gonna figure this out on my own some other time, and that's gonna be for today's stream. Thank you so much for joining. Thank you for subscribing as well. We've jumped by 2 subscribers.